start recording. There we go. Thank you. Excellent. So, what is electrostatic attraction? What do you think? Yes? It's static electricity, and it doesn't even have to be on a small scale. It can be on a large scale or whatever. But it would be the attraction between now, if you think about gravitational attraction is the attraction between one thing that has mass and a second thing that has mass. What is this electrostatic attraction and attraction between?
Electricity.
Electricity, yes. Specifically, what things?
Electrons.
Electrons, could be electrons. What kinds of things would electrons be attracted to? They would be attracted to positive. So what would we call those negatives and those positives?
Ions.
They could be ions, but they don't have to be, because you could have an electron. Anions and cations, they could be, but they don't have to be, because you could have a nucleus that's positive and it's not an ion. It's easier than you think. Yes? Charges. So a Coulombic attraction is an attraction between positive, that's supposed to be a circle, and negative charges. And if we want to become a little bit more broad in our definition, we could all call it a Coulombic force. And that is the attractive or repulsive force between charges. Oh my God, I'm just going to write it down so you don't have to listen to me say that. Stopping now. BW is between so we've already said that positive and negative attract. What do positive and positive do? They repel. And negative?
Well.
They repel. All bonds and intermolecular forces are the result of Coulombic attraction. In an ionic bond, what are the positive and negative things that attract? have a little chit chat with your neighbor about that. What are the positive things and negative things in an ionic bond that attract? I didn't hear much discussion, so I assume you guys are still writing and you're going to be discussing it once you've finished writing. Again, this is easier than you think. If you're having trouble with it, it is easier than you think. What are the things that are positive and negative in an ionic bond? An anion and a cation, right? You've got the negative anion and the positive cation. Okay, so what we would have is we would have a negative ion, we would have a positive ion right beside each other, and in between them, we would have that Coulombic attraction, which is an ionic bond in this case. Okay, and it would form a lovely little what? This is in miniature. A crystal lattice, yes. Okay. Now, theoretically, it should be in 3D and it should be a lot bigger than that, but, you know, we're simplifying. In a covalent bond, what are the positive and negative things that attract? This one's a little trickier. And you might want to look back at the last set of notes we took last, whatever day the last fire bell was. We took some notes. They looked like, let's find it here. Oh, these ones. Yes? Do you remember these ones? Okay, you might want to take a look back at those, at our little covalent bonds. Yeah? Because that might help you think about it. Yes. Electrons and protons, yes. Okay. Specifically, let's try that Y again. Specifically, the positive nuclei. You guys are okay with the plural of nucleuses is nuclei, okay? The positive nuclei and the negative shared bonding electrons. So what we would have is if we had a hydrogen and a hydrogen, which we could also write like this. At the center of each hydrogen is the nucleus. And that's just one proton in hydrogen, okay? And then in between, we have those little electrons and they're negative. Those are what those little dashes mean. That means it's negative. Maybe I should make them in red or something so it looks a little different. Otherwise, they all just look like dots. Here, let's make the dot bigger. There we go. And that's negative and that's negative. And this nucleus attracts those electrons, and this nucleus attracts those electrons. So you can imagine, what if we didn't have those electrons in between? What would the nuclei do to each other? They would repel each other. But fortunately for us, we have those electrons in between. Okay, so these here together these Coulombic forces here make up a covalent bond. What are the positive and negative things that allow water molecules to experience IMFs, or intermolecular forces? Have a little chit chat with your neighbor about that one. Maybe you could see if you could draw a little picture like we did for the ionic bond and for the covalent bond. You don't have to write, so you can see if you can draw a picture. You can just draw the picture. Try drawing the picture. If you have to cross it out later, that's fine. I don't see a lot of drawing taking place. I see some people drawing and some people talking and most people sitting. I'll get you started. Here's a water molecule. And if you've forgotten, maybe you could look back at this here. Okay, Addie, what do you think? Yeah, we get an attraction between the slightly negative oxygen right? And in another molecule, we'll have a hydrogen that is slightly positive. And so between the two of those, what will you get?
IMFs.
Those little intermolecular forces. I should just write IMF because we all know it stands for intermolecular force and it's just tedious to write it all out. Is this making sense? So every single force that is holding chemicals together is caused by these electrostatic attractions, by these Coulombic attractions. Okay? That's the main takeaway message. And I think that was all we needed to cover. So that's good news. And now we need to talk about what's happening for the rest of the week. So Thursday we have the Terry Fox run, so it's a little bit of a shorter day. Okay. Wednesday we have your quiz, and I wanted to make sure that everybody saw on Teams, like up here, that we have down in our Upcoming quizzes and tests, I've updated it with a little extra practice if you want it. Okay, so for sections 5.3 and 5.4, extra practice is 5.6a, pages 102 to 104, number 23 to 50, and that is in the upcoming quizzes and tests channel. Yes?
What textbook is it on?
This is in our workbook.
Oh, no.
Okay? This is in our workbook. If you want stuff from Hebden, I can find you stuff, but I would say do these first because they're probably more directly related. Yeah, so if tomorrow you're like, I would like more, I can tell you what's in Hebden and stuff. Okay? And then the next thing is that leaves us tomorrow to do the lab with making a solution. You remember you picked up those 3 long pages? If anybody has not yet picked it up, they are over here underneath the clock. Okay? Preparing the solution, blah, blah, blah. There's a pre-lab assignment, whatever. Okay? And what that means is that you need to do for tomorrow, your homework, like grade 9 homework. Oh, it's so messy. Number 1, you're going to do the pre-lab assignment. Okay, and number 2, you're going to do what? It's part of the pre-lab assignment, but you're going to make sure you've read the pre-lab vocabulary. Okay? Read the pre-lab vocab. Okay, now, in order for you to do that, I did want to just take a quick look at it with you. Okay, so we have lab number 1, preparing and observing a solution pre-lab assignment. So what you're going to do for your pre-lab assignment is, because this lab actually does have some things that are dangerous in it, okay? You could, in theory, seriously hurt yourself doing this lab, okay? The most important rule is going to be don't touch hot things, okay? But there's a whole bunch of rules here, okay? So what you are going to do is you are going to read, and then on your own paper, you are going to draw labeled diagrams illustrating each of the safety procedures to make sure that you have internalized them. Yes? And this will be part of your lab mark. So, for example, number 1 says calcium hydroxide and its solution, lime water, are bases. Do you guys know what ion makes something a base? Hydroxide, okay, the OH ion. Okay, bases are chemicals that contain the hydroxide ion. Bases are skin irritants. Wash any spills on your skin or clothing with plenty of water. Okay, wash until it no longer feels slippery. Okay, now, how are you going to draw that? Well, what I would do, I've shown you my little thing. Number 1, if you have CaOH2, you have a base. And if you get it on your hand, ow. Yes? Except for it won't actually hurt. Acids will actually hurt you a little bit. They'll sting, they'll feel itchy, and you'll know that an acid on your skin is there. However, a base won't feel like anything. So it will just eat away at your skin without you knowing. Okay? So the trick with a base, do you know what bases feel like? Like if you rub them like that? Slippery. Okay? So if you get some on your hand or somewhere else, you are going to wash until it is Not slippery. And you can see you do not need any sort of drawing ability to be able to do this, because I don't know what that thing is. It's supposed to be a hand. It kind of looks like it might be a wing or a paw or just some random set of lines. I don't know. It's really bad, but you can draw anything you want. It does not have to be beautiful. I'm not expecting like you to spend all day, you know, shading in, making it 3D. No, like this is perfectly acceptable. It's kind of like, you know, when you're playing those games and you have to guess what the person's drawing and like whatever. It's all good. Okay. So you're going to do that. I was going to say something else. What was it? It slipped my mind, but it would come to me. It's okay. Diagrams or drawings, like whatever, as long as, and you can use words in there, just so long as you've got, sort of got like, I did not slippery. How are you going to draw not slippery? And I don't want you, you know, going too crazy, like sounds like, you know, that just, you guys have no idea what I'm talking about, do you? No? Did you never play Pictionary or any of those games? Like where you have to draw things and you'd be like, sounds like... That's supposed to be a knot. So, sounds like knot. Ha ha ha. Okay. Anyway, we're not doing that. You don't have to do that. You can just write not slippery because that's too hard to figure out how to draw that, right? Or you could be like banana peel. No, just don't go that far. Okay? Just, it's fine. Labeled drawings and diagrams are fine. The vocabulary is here. Okay, on the main sort of lab sheet, you've got your pre-lab vocabulary. So make sure that you have read through and have an understanding of what those words mean. Okay? And look at the pictures and all that good stuff. What else? That's it. Okay, cool. Yeah. If you want to wear glasses that day, you can wear glasses and then you don't have to wear safety glasses. So if you're one of those people who sometimes wears contacts, might be a good idea to wear glasses tomorrow. All right. And I think that's it. Now, so that's it for the lab. We'll just do that tomorrow. And now I want to do something that will help get you ready for your quiz on Thursday. And that is you are going to actually make a solution. Yay. So you're going to actually physically do it.
This one.
Yes.
On Wednesday, right?
Quiz is on Wednesday. Did I say Thursday? Oh, that's because our last quiz was on Thursday and my brain is still doing that. So yes, your quiz is on Wednesday. Okay. And one of the things you're going to need to be able to do on that quiz is describe how to make a solution. So today you are going to get a making solution mini lab. It says part 1, we'll do part 2 later when we do solutions and dilutions, okay? This is just a little lab skill. And on the front page, there's an area for your calculation, and then it gives you the procedure, okay? Also, though, to make it more visual for you, on the back, there is a visual procedure, yes? So you'll be using this. Now, in an ideal world, you would be using electronic balances, but they are in use today, so we are going to be using the triple beam balances, but it's okay. We've got like 40 minutes. We'll have lots of time, okay? And my other block, we had more to cover because they had like the fire bell and stuff, and so the stuff I taught you took more time for them. So if you want, when you are making this solution, you can ask me to show you how to use parafilm rather than a stopper to put on top of your flask, because it's really fun. Okay, so when you get to the point where you need to stopper your flask, there are stoppers back there. They're in a little jar, okay, and you can just pop the stopper on. And if that's all you want to do, that's fine. But if you would like a little lesson in parafilm, I will give you a little parafilm lesson. And it is super fun, and I will show you that at that time. The other thing is that we have two types of funnels, okay? This one, skinny, fits nicely into the flask, volumetric flask, but the salt will get stuck in it. Yes? So we don't want to use that one. Unfortunately, our other size funnel is too big and it does not fit inside. So what you're going to have to do is you're just going to have to hold the two together. And it works quite nicely. Okay? Like it's not a big deal. It'll, and if you have trouble, call me over and I can help you out with it. Okay? So I don't think I'm going to actually give you any instructions other than to point out that the water bottles are on the back shelf. I will go grab a few more because it looks like we don't have enough for our class. Okay. Scupulas are, the salt's here. Salt is here. You can see this was all leftover salt. I got 3 bowls of it. They took a lot of salt. You're like, look at your amount and figure out how much you think that's going to be. And you can always come back and get more. You don't need to take like whole huge amounts of it. I'm not really impressed by the fact that these did not go back. So when you guys do this, you're going to put them back in the actual containers rather than leaving them on the counter. Although that's probably my grade 9s that did that because they were doing stuff with Bureau. So I'm just realizing I'm probably maligning block 2 and it was probably my grade 9s. What else? Scupulas. These are scupulas. So you can use them to transfer salt from one beaker to another beaker. Yes, because you'll need to have one beaker where you carry the salt and one beaker on your balance. And it doesn't matter what size, you can use 100 milliliter, 50 milliliter, like whatever, okay? 250, doesn't matter. Medicine droppers. We don't have a whole lot here. You can kind of share them around, okay? I'll see if I can find some more in our back room there. All right? Anything? Yes. Yes. The procedure. You might need to write down the procedure. Yes. There's only 6 steps. And they should all make logical sense. Right? Like you have to measure out the correct amount, right? Like weigh out the amount. Then what are you going to do with it? You're going to put it in the flask. Then what will you add to make a solution? Water. And then, like if you fill it with water to the line with the mark, you won't be able to swirl it very well because there's not enough air. So you're only going to fill it halfway at first, and then you'll be able to swirl like crazy to dissolve it. And then you'll add water to the line, and then you'll put the stopper or the parafilm on top, and you'll invert it to get a final mix. That's it. Right? Like if you logically think about it, like how else could you make it? The only one that's a little bit weird is fill it up halfway with water and swirl so that it all dissolves. That's the one that's kind of a little bit, but how else would you do the rest of it, right? I guess you could put the water in first, but you just have to learn, put the solid in first. There you go, done. Okay, so I will give you each one of these. Once you have your calculation, show me your number and I will check you off just to make sure you're measuring out the right amount. Okay. You can work with a partner, or with 3, or by yourself. It doesn't matter. Okay. 2, 3, 4, 5. There we go. Oh, you're like, there's way too many. It's because it's for them, yeah. Okay. Yes. Both of you should do it just so you get used to like showing your work for the calculation while you practice for calculation.
Okay, Dorothy. This one. Okay, so we do a map, right? So we go from. Wait, we're trying to go from milliliters to moles, right? Oh, but you're doing to change that to grams to right like that. Grams.
Remember to check your number with me?
Your rates are so good. Wait, milliliters to moles. And then do that. So we're trying to find the number of grams. Yeah. Probably these round up and. For one, there's 0.05, right? One
So, 15 is the water.
23. So equal. So you get 0.0. Wait, this has this has
I don't know, this is.
we have to put in.
So like.
You can, when you're making a calculation for what you're measuring out, you can just keep all the digits you want to, and then just go to whatever your measuring device will allow you. Do you know what I mean? Because, you know, don't round off if you don't have to for making the measurement. Yeah.
Wait, what is it?
Folks, you don't need to round to sig figs here. Okay, because you're making a measurement of, like, you're calculating how much you want to measure out, and you want to avoid rounding as much as possible. You'll get the most accurate result, okay? Hmm?
Okay, now we got to fill this out. Measure out. Oh, this one. No,
That is nice.
Measure 4,683.
Oh,
She said, don't what?
Oh, it is. Okay, good. Yeah. Oh, we forgot to cover anything on this.
Yeah, in milliliters, this should be liters. So the one on this.
Yeah.
This one. No wonder it looks weird. 4,000.